In today's video, we'll be looking at how to solve direct proportion worded problems, alright? And as always, if you are new to this channel, please hit that subscribe button. Don't forget to give this video a thumbs up and click the notification bell to be notified whenever we post new videos. Alright guys, so as mentioned in the initial stages of the video, we want to look at how to solve direct proportional worded problems, alright? But first, we need to get an understanding of what direct proportion is all about, alright? So in direct proportion, as one variable increases, the other variable will also increase, alright? And the same is true. If one variable decreases, the other variable will also decrease, alright? So that's pretty much what direct proportion is all about. And to give you a better understanding of what this thing is saying, let us look at a worded problem example of a direct proportion scenario. All right. So here we have Chanel can make 17 cakes in 8 hours. How many cakes can she make in 2 days? All right. So what you would have noticed, all right, or what you should have noticed is that the two variables here would have been cakes and time. All right, so we can make this cakes and hours. So what you could do is to convert this day to hours. And of course, 2 days is the same thing as 48 hours. Now, what I wanted to look at is that if Chanel can make 17 cakes in 8 hours, she should be able to make more cakes in a 48 hours period, all right, which is the same thing as 2 days. So 2 days is more than 8 hours. So if she can make 17 cakes in 8 hours, she should be able to make more cakes in a 2-day period, all right? Which simply means if the amount of hours increase or if the time increases, the amount of cakes that Chanel can make will also increase, all right? So hopefully that makes a lot of sense. So that's pretty much what a direct proportional scenario is all about. If one variable increases, then the other variable must also increase in order for that to be considered to be a direct proportional problem, all right? Now let us look at some questions. All right, so here we have question 1. So in a business, if Abby can earn $7,500 in 2.5 years, which is the same thing as 2.5 years, at the same rate, find her earnings for 4 years, all right? So we want to know how much money Abby can make over a 4-year period. And of course, this meets the criteria of being a direct proportional scenario, all right? So think about it. If she can earn $7,500 in 2.5 years or 2.5 years, then she must be able to make more money over a 4-year period, all right? So if the amount of years increase, then she should be able to earn more money, all right? That means this is a direct proportional problem, all right? What we can do now is to highlight the two variables. So think about it. Here we have money, or we could call it earnings, or whatever thing you want to lend to this that relates to money, you can do so, all right? I'm going to call it money, all right? And we are also treating with years, all right? And this is the shortcut method that I promised you guys. So if you would have watched that video that I have on the direct and indirect proportional lesson, all right, where I taught this concept in detail. So if you haven't watched that video as yet, please check that out. I'll have that video in the description section below titled Direct and Indirect Proportion Lesson, all right? That's where you learn this concept in detail. So you learn about the formula, y equal kx and all of that. So if you want to learn this thing in more detail, please check out that video, all right? Now let's get right back to this, all right? So we know that she earned $7,500 in 2.5 years. All right. And now they want us to know what? They ask us to find her earnings, which means we don't know this thing. We don't know her earnings for 4 years. All right, so notice how I set this thing up. So she'll earn $7,500 in 2.5 years. All right, so I put the dollars underneath the whole money variable right here. Put the years underneath the years variable. All right, then they ask us to find her earnings for 4 years. All right, which simply means we don't know the amount of money that she'll earn in the 4 years. All right, so we use a X to represent that. All right, so I put the 4 over the years section. What I can now do, being that this is a direct proportion problem, we can cross multiply. All right, so if I do that, I'll end up with x times 2.5, which is 2.5x, is equal to 4 times 7,500, which is 30,000. All right, now what I can do to obtain the value of x is to divide both sides by 2.5. All right, so 2.5 will cancel 2.5 and I'm left with x is equal to $12,000. All right, so this would have been our solution to this problem. All right, so quite easy. So this is the shortcut method that I promised you guys. All right, so this is pretty much how you treat with a scenario like this one. All right, and you can use this method to solve any direct proportional problem. All right, now let us look at question 2. All right, so here we have question 2. So in 36.5 weeks or 36 and a half weeks, Miguel raised $2,372.50 for cancer research. How much money will he raise in 20 weeks? All right, so what I want to know is how much money Miguel will raise in 20 weeks. All right, so if he can make $2,372.50 in 36 and a half weeks, then he should make less money in a 20-week period. All right, so this is a direct proportional problem as well. All right, so if the weeks decrease, then the amount of money should decrease as well. All right, and look how we can set this thing up. Of course, the two variables would be weeks and the amount of money that he'll earn. All right, so here we can have what? Weeks. We can have weeks and money. So we'll have in 36 and a half weeks or 36.5 weeks, he'll make $2,372.50. All right, what we want to know now is how much money. All right, so we don't know the amount of money he'll make in a 20 weeks period. All right, and of course, being that this is a direct proportional problem, we can simply cross multiply. So we'll have what? 36 and a half times x, or 36.5 times x. That will give us 36.5x, which will be equal to 20 times 2,372.50, which will give us 47,450. All right, what we can do now is to divide both sides by 36.5. All right, so 36.5 will cancel 36.5 and I'll be left with x is equal to the result that I'll get when I divide 47,450 by 36.5, which is $1,300. All right, so this would have been our solution. And what you guys can always do, you can put this in a statement if you so choose to give clarity to what you would have done up here. All right, so you can say, therefore, Miguel would raise $1,300 for his cancer research in a 20 weeks period. All right, so if you so choose to, you can do that as well. All right, just to give clarity to the calculations that you would have performed here. Now let us look at question 3. All right, so here we have question 3. So you have found that a good ratio of pizzas to people is 1 to 3. You are having a class reunion and there will be 12 people there. How many pizzas do you need for the class reunion? All right, so I want to know how much pizzas that you will need for the 12 people that will be at the class reunion. So first thing first, we need to identify the two variables. All right, so remember the outline that what? A good ratio of pizzas to people is 1 to 3. All right, so pizzas to people. So the two variables would have been what? Pizzas and people. All right. So what do we know about that? We know that the ratio of pizzas to people, we know that one pizza can serve 3 people. All right. So what they want us to know now is how much pizza will we need for the 12 people that will attend the class reunion. All right. So I'll put the 12 over where we have the people. We don't know the amount of pizza as yet that we'll need. All right. And as always, being that this is a direct proportional scenario, because think about it, the more people we have, the more pizza that we'll need. All right. So what we can do now is to simply cross multiply. All right. Because this is a direct proportional problem. So 3 times x will give us 3x is equal to 12 times 1, which is 12. And what we can do next is to simply divide both sides by 3. So 3 will cancel 3 here. And x will be equal to 4 pizzas. All right. And as always, you can write a statement for this thing right here. So you can write a statement. So therefore, 4 pizzas will be required for the 12 people that will attend the class reunion. All right. If you so choose to, just to give clarity to what you would have done. All right. So now let us look at question 4. All right, now let us look at question 4. All right, and this was a problem that I used, all right, to help you to identify a direct proportional worded problem. All right, so here we have Chanel can make 17 cakes in 8 hours. How many cakes can she make in 2 days? All right, and of course, the two variables here would have been cakes and time. All right, and I'm going to choose whether I want to use the hours or days. In this case, I'm going to use the hours. All right, and of course you could have used these as well. All right, I just think this thing will look a lot better if we choose to use the hours. All right, so Chanel can make 17 cakes in 8 hours. All right, then they ask us how many cakes can she make in 2 days. All right, so 2 days is the same thing as 48 hours. Because there's 24 hours in a day. So of course, 2 days will consist of 48 hours, all right? And they ask us how many cakes. That means we don't know the amount of cakes that she'll be able to make in the 48 hours, all right? Being that this is a direct proportional problem, we can cross multiply, all right? So 8 times x will give us 8x. And this will be equal to 17 times 48, which will give us 816. And what we can do now is to divide both sides by 8. 8 will cancel 8 here, and x will be equal to 102 cakes. All right. So as I always mention, you can write a statement here. So therefore, Chanel can make 102 cakes in a 2-day period. All right. So if you so choose to do that. Now let us look at question 5. All right, so here we have question 5. So you are using a recipe for meatloaf that calls for 10 ounces of ground beef. The recipe is for 5 servings, but you want to make enough for 8 servings. How much ground beef should you use? All right. So as always, the first thing that we want to do is to identify the two variables. All right. So of course, the two variables would have been what? We're dealing with the ounces of ground beef, all right? So we're dealing with the ounces of ground beef. And the servings, all right? So we know that what? We know that 10, so remember they say what? You are using a recipe for meatloaf that calls for 10 ounces of ground beef, all right? The recipe is for 5 servings. So this right here, the 10 ounces of ground beef is for 5 servings, all right? So the 10 ounces of ground beef, we can get 5 servings out of that. Alright? Then the further on go on to ask us what? How much ground beef should we use if we want enough for 8 servings? So I want to know how much ground beef we'll need for 8 servings. Alright? So I have to put all of the servings over underneath the heading where we have servings. Alright? And being that this is a direct proportional problem, we can cross multiply. So x times 5 will give us 5x is equal to 8 times 10, which is 80. Alright, and what we can do now is to simply divide both sides by 5. So 5 will cancel 5, and x will be equal to 80 divided by 5, which is 16 ounces. Alright, so this is pretty much 16 ounces of ground beef. Alright, so therefore it will require 16 ounces of ground beef to make enough for 8 servings. Alright, so you can always do that. Now let us look at question 6. Alright, here we have question 6. So one jar can hold 35 cupcakes, and 11 cups of flour are needed to make 5 cupcakes. How many cups of flour are required to make enough cupcakes to fill 7 jars? Alright, and this is a very interesting problem. Alright, so what I'll advise you guys to do is to actually go ahead and write out the information that you would have got. So we know that one jar is equal to 35 cupcakes because they told us that one jar can hold 35 cupcakes. Alright, so we can say one jar is equal to 35 cupcakes. Alright, what else did they tell us? They tell us that what? 11 cups of flour is equal to 5 cupcakes. So we know that 11 cups of flour is equal to 5 cupcakes. Alright, and then they ask us how many cups of flour are required to make enough cupcakes to fill 7 jars. So the first thing that we need to ask ourselves is how many cupcakes is required to fill the 7 jars. Alright, so after we would have found out the amount of cupcakes that is needed to fill the 7 jars, we can then find out how many cups of flour it will take to make those cupcakes that will fill the 7 jars. Alright, so hopefully that makes a lot of sense to you. Alright, so the first step, I'm going to find out how many cupcakes it will take to fill the 7 jars. Alright, so I'm going to do a proportion with jars and cupcakes. Alright, so that's the first thing that I'm going to do. So I know that one jar can hold 35 cupcakes. Now I want to know how many cupcakes can hold in the 7 jars. Alright, so how many cupcakes? I don't know as yet, so I put an X for that. Now what I can do is to cross multiply here. Alright, being that this is a direct proportional scenario. So x times 1 is x is equal to 7 times 35, which is 245. Alright, so 7 jars can hold 245 cupcakes. Alright, 245 cupcakes. Alright, what I want to know now is how many cups of flour will it take to make this 245 cupcakes. Alright, and that will give me the amount of flours that is required to make enough cupcakes to fill the 7 jars. Alright, so hopefully that started to make a lot more sense to you now. Alright, because we would have already known the amount of cupcakes that it will take to fill the 7 jars. Now all we need to know is the amount of cups of flour that it will take to make these 245 cupcakes. Alright, so what we can do now is to set up a proportion with cups of flour and cupcakes. Alright, so we have cups of flour and cupcakes. Alright, so remember, based on the information that we recorded, it takes 11 cups of flour to make 5 cupcakes. Alright, so 11 cups of flour is equal to 5 cupcakes. Now we want to know how many cups of flour, which is X, will it take to make the 245 cupcakes? Alright, and we can cross multiply. Alright, being that this is a direct proportional scenario. Alright, so what will we have now? X times 5, that will give us 5x, and 11 times 245 will give us 2695. Alright, now what we want to do now is to divide both sides by 5. So here we'll have 5 will cancel 5, and x will be equal to the result that we'll get when we divide 2695 by 5, which is 539. Alright, cups of flour. Alright, so therefore it will take 539 cups of flour to make enough cupcakes to fill the 7 jars. Alright, so it will take 539 cups of flour to make enough cupcakes to fill the 7 jars. So this would have been our solution, and that is how we treat with a scenario like this one. Alright, and you can always pause and rewind and do what you need to do to get a better understanding of how I went about solving this problem. Alright, so that's pretty much how we treat with a problem like question 6. And of course, there are more than one ways to solve a question like this one. Alright, but I'm trying to give you guys one standard method that you can use to solve any direct proportional problem. Alright, so what we can do now is to look at question 7. Alright, so here we have question 7. So if 270 kilograms of corn would feed 42 horses for 21 days, for how many days would 360 kilograms of corn feed the same 42 horses? Alright, so of course the two variables here would have been what? Kilograms of corn. Alright, so kilograms of corn, and the amount of days the feed will last. Alright, so the feed will last. So what we know is what? We know that 270 kilograms of corn will last the 42 hours for what? 21 days. Alright, now what we want to know is how many days. So we don't know the amount of days. 360 kilograms of corn will last the same 42 horses. Alright, and we know how to treat with this already. So being that this is a direct proportional problem, we can simply cross multiply. So we'll end up with what? 270 times x, which is 270x, is equal to 21 times 360, which is 7,560. And what we can do now is to simply divide both sides by 270. Alright, when we do that, 270 here will cancel 270 down here, and x will be equal to 28 days. Alright, so what we can always say is that the 360 kilograms of corn feed will last the 42 horses for 28 days. Alright, as I always mention, you can have a little statement there to give clarity to what you would have done up here. Alright, so let us look at the final question for this video, question 8. Alright, so here we have question 8. So a stick 4 meters long is held perpendicular to the ground. Alright, so we know that if we hold a stick perpendicular to the ground, then that simply means we would have hold that stick upright. Alright, which simply mean the length of the stick would simply be the height of the stick. Alright, so the height of the stick would actually be 4 meters. Alright, and cast a shadow of 0.75 meters long. At the same time, an electrical tower casts a shadow of 148 meters long. Calculate the height of the electrical tower. Alright, so as mentioned before, the length of the stick is simply the height of the stick. So we can compare the height of the objects. Alright, so the height of objects. Alright, so I don't have the of here, just put it in right there. So the height of object versus the length of the shadow of the objects, all right? And I'll just stop that at length, all right? So the length of the shadow of the objects. Now, let's look at this. Now, the stick has a length or height of 4 meters, all right? And when it has a height of 4 meters, it casts a shadow of what? 0.75 meters in length, all right? What else do we know? We know that a tower casts a shadow of what? 148 meters long. So we'll put that over here. And they ask us to find the height of the tower that we don't know, which is x, all right? And as always, being that this is a direct proportional scenario, we can simply cross multiply here. So x times 0.75 will give us 0.75x. And 4 times 148 will give us 592. Now what we want to do is to divide both sides by 0.75. All right. So 0.75 will cancel 0.75. And x will be equal to 789.3 meters. All right. So therefore the height of the tower would actually be 789.3 meters. All right. So that's where we'll end today's video, guys. Don't forget to like this video, and if you haven't yet done it, please hit that subscribe button and the notification bell to be notified whenever we post new videos. All right, as always, thanks for watching.